Features-based matching algorithms. As opposed to area-based techniques, the features-based techniques need an image preprocessing before the image matching process, see. This preprocessing consists of a feature extraction stage from both images, resulting in the identification of features of each image. In turn, some attributes have to be extracted to be used in the matching process. Thus, this step is closely linked to the matching stage in those matching algorithms based on features because, without this step, the algorithm would not be able to have enough information to make inferences and obtain the image correlation. Area-based and features-based algorithms. For features-based stereo vision, symbolic representations are taken from the intensity images instead of directly using the intensities. The most widely used features are breakpoints, isolated chains of edge points or regions defined by borders. The three above features make use of the edge points. It follows that the endpoints used as primitives are very important in any stereo vision process and, consequently, it is common to extract the edge points of images. Once the relevant points of edge have been extracted, see, some methods use arrays of edge points to represent straight segments, not straight segments, closed geometric structures which form geometric structures defined or unknown. Edge detections in a features-based algorithm. Aside from the edges, the regions are another primitive that can be used in the stereo vision process. A region is an image area that is typically associated with a given surface in the 3D scene and is bounded by edges. With the amount of features and depending on the matching method that will be used, an additional segmentation step may be necessary. In this step, additional information would be extracted from the known features. This information is calculated based on inferences from the known characteristics. Thus, the matching algorithm that receives the inferred data possesses much more information than the algorithm that works directly on the pixel intensity. Once the algorithm has both vectors with the inferred features from the two images, it searches in the vectors looking for similar features. The matching algorithm is limited to a search algorithm on two features sets. So, it is understandable to say that the bulk of computation corresponds to the feature extraction algorithm and the inference process. This fact will affect to the system it is going to be located in a real-time system with a low power consumption it is difficult to use this kind of algorithm. The main advantages of these techniques are better stability in contrast and illumination changes. Allow comparisons between attributes or properties of the features. Faster than area-based methods since there are fewer points, features, to consider, although require preprocessing time. More accurate correspondence since the edges can be located with greater accuracy. Less sensitive to photometric variations as they represent geometric properties of the scene. Focus their interest on the scene that has most of the information. Despite these advantages, features-based techniques have two main drawbacks, which are easily deduced from the characteristics described above. The first drawback is the high degree of dependence on the chosen primitives of these techniques. This can lead to low quality or unreliable results if the chosen primitives are not successful or are not appropriate for these types of images. For example, in a scene with few and poorly defined edges, delimiters would not be advisable to select regions as primitive. Another drawback is derived from the characteristics of the preprocessing stage. Previously, this step was described as a feature extraction mechanism of the two images and the inference or properties of the highest level in each of them. As stated above, there is a high computational cost associated to this preprocessing stage, to the point that using digital cameras with existing high-level algorithms running on powerful machines cannot match the real-time processing. However, in general-purpose equipment, this technique is the most commonly used because of its results. In classic machine vision, this research branch has been the most deepened in, P. J. Herrera et al., 2009, D. Scaramuzza et al., 2008, P. Primerit and S. Safai, 2008. With these explanations, a global perspective to matching algorithms has been presented as well as classified in different types. All of them have been exposed and evaluated with their advantages and drawbacks. Next, this work introduced the reader to the concept of neuromorphic engineering and, after that, a stereo matching approximation to a neuromorphic system is shown.